In this lesson, we will define oxidation and reduction in terms of a gain or loss of electrons. Now that we can assign oxidation numbers to all atoms involved in a reaction, we can see how the reaction is occurring. And in this case, we have two processes that occur. One is known as oxidation and the other is known as reduction. And they must occur together because we're dealing with the transfer of electrons. If someone is gaining electrons, someone must be losing electrons. Together, we call these redox for short rather than writing out oxidation reduction. After we assign oxidation numbers to all atoms in a reaction, we need to determine which process is the oxidation and which process is the reduction. For oxidation, we will see the loss of electrons, which will result in an increase in the oxidation number. Remember that electrons have a negative charge, so losing an electron will result in an increase in the oxidation number. A reduction occurs when there is a gain of electrons and a decrease in the oxidation number. As the oxidation number reduces, it's a result of the gain of electrons. Here are a couple of mnemonics that may help you remember the oxidation and reduction process. Leo the lion says grr for lose electrons oxidation, gain electron reductions. Or oil rig, oxidation is loss of electrons, reduction is gain of electrons. Let's look at a couple of examples of reactions and determine which species are being oxidized or reduced. First, we need to assign oxidation numbers for every atom in the reaction. For hydrogen, it's a free element, so it has an oxidation number of 0. Bromine is also a free element, so it has an oxidation number of 0. For HBr, we know that hydrogen has an oxidation number of +1. Therefore, Br must have an oxidation number of -1, because the sum of my oxidation numbers must equal 0. Note that the coefficient does not play a role. When we determine the oxidation numbers for atoms in a compound, we ignore the coefficients. When we look at hydrogen on the reactant and product side, we see that the oxidation number goes from 0 to +1. This is an increase in the oxidation number, so this is known as oxidation. While we don't explicitly see the loss of electrons, know that it is happening. For bromine, we go from an oxidation number of 0 to an oxidation number of -1. We are decreasing the oxidation number as a result of gaining electrons, so this is known as a reduction. Again, we need to assign oxidation numbers to every atom in a reaction. We know that hydrogen is +1. If we have +4, then the carbon total must be -4, and there are 2 of them, so the oxidation number of carbon is -2. O2 is a free element, so it has an oxidation number of 0. In CO2, we know that oxygen has an oxidation number of -2, and there are 2 of them, so we know that carbon must be +4. In water, hydrogen has an oxidation number of +1, and oxygen has an oxidation number of -2. In looking for species that are changing, we see that the carbon changes from -2 to +4. This is an increase in the oxidation number, and this will be known as the oxidation process. If we look at oxygen, it goes from a 0 to a -2, and this is known as reduction because we see a decrease in the oxidation number.